Waves in strings, question 1, part A. In the equation for the fundamental frequency of a stretched string, frequency is equal to 1 over 2L root T over mu. What is represented by the symbol mu for 1 mark? Well, this isn't quoted on your datasheet, so you really need to remember it. It's the mass per unit length of the string. You could work out what the units are to give you a hint, but it's quite a long-winded way of getting 1 mark. Part B. Explain with the aid of a diagram how you would test the relationship between frequency and mass per unit length of the string. State what you would keep constant, how you would use the data obtained. Well, there are 9 marks for this question, but it is broken down into several parts for us. It says with the aid of a diagram, so they are expecting a diagram. There'll be at least 2 marks for details on the diagram. How you would test the relationship, the method you would employ. In general, when testing a relationship, we change something, we measure something, and we keep everything else the same. Should be at least 2 marks for these details. What we would keep constant? Well, that would give us at least 2 marks for factors we need to keep constant. And how we would use the data obtained, what graph we would plot. So if we aim on at least 2 to 3 marks for each of the different parts of the question, we should pick up most, if not all, of the 9 marks. Well, first the diagram. We need a length of string. This is our length L of string between the 2 supports. We can produce tension in the string by means of these masses, and we can make the end vibrate by means of the signal generator. And we can read from the signal generator the frequency of the vibration generator. I've reproduced part B on this page just so we can refer to it. Well, now we need to state how we would test the relationship between F and mu. So what we need to do is use several strings of different mass per unit length. This is what we're going to change. We're going to change mu, and we're going to measure F. The way to measure F would be to find the fundamental frequency by adjusting the signal generator to alter the frequency of the vibration generator until there is a standing wave of half a wavelength, like this, between the vibration generator and the pulley. We can then read off the frequency of the signal generator for each of the different strings. Now, to state what we would keep constant, well, we must keep the length and the load or tension constant. And how we would use the data obtained. This is what graph we would plot. Well, reproducing the equation here for reference, we're looking at the relationship between the fundamental frequency F and the mass per unit length mu. Now, if we compare this to the equation y equals mx plus c, the general equation where m is the gradient and c is the y-intercept of a straight line graph, we could plot our fundamental frequency as our y value. We could plot 1 over the square root of mu as our x value. The gradient would then be 1 over 2L square root of t, and there would be no y-intercept. It should be a straight line through the origin. Something like this, with the fundamental frequency in units of seconds to the -1 or hertz on the y-axis, and 1 over the square root of mu, the mass per unit length, which would be in units of kilograms to the -1/2, meters to the half. In a longer question like this, there'd often be marks for quality of written communication. This doesn't mean you need to write a perfect essay. What it does mean is that you must use the correct terminology, spell the words correctly, and put them together in some sort of logical sequence. Bullet points are generally fine.